Hello class, in this video I will be showing you how to solve a logarithmic equation. Let's begin. In example 13 we want to do two things. We want to determine the domain of the variable and solve the equation. To determine the domain of the variable, we will start with the fact that x minus 2 must be greater than 0 and x plus 2 must also be greater than 0. This implies that x must be greater than 2 and x must be greater than negative 2. Since 2 is already greater than negative 2, the domain of the variable is the open interval from 2 to infinity. This means that all solutions must be greater than 2. To solve the equation, I'm going to apply the product rule of logarithms. I'm going to rewrite the equation as log base 2 of x minus 2 times x plus 2 has to equal 5. Multiplying the binomials, you'll get log base 2 of x squared minus 4 has to equal 5. To solve this logarithmic equation, I'm going to convert it into an exponential equation. Since the base of the logarithm is 2, the base of the exponential equation will also be 2. So this is 2 to the 5th power is equal to x squared minus 4. 2 to the 5th power is 32. And if I subtract 32 from both sides, I will have x squared minus 36 is equal to 0. X squared minus 36 factors as x minus 6 times x plus 6, which means that x is equal to 6 or x is equal to negative 6. Since negative 6 is not greater than 0, x is equal to negative 6 is an extraneous solution. This means that the only solution to this equation is x is equal to 6. Now let's take a look at another example. In example 14, we want to find the domain of the variable and solve the equation. To find the domain of the variable, we will start with the fact that 2x minus 3 must be greater than 0 and x plus 5 must also be greater than 0. This implies that x must be greater than 3 halves and x must be greater than negative 5. Since 3 halves is greater than negative 5, the domain of the variable is the open interval 3 halves to infinity. This means all solutions must be greater than 3 halves. To solve the equation, I'm going to apply the quotient rule. So I'm going to rewrite the equation as the natural log of 2x minus 3 divided by x plus 5. That is going to equal 0. Rewriting this equation as an exponential equation, we have e to the 0 power is equal to 2x minus 3 divided by x plus 5, which means 1 is equal to 2x minus 3 divided by x plus 5. The only way a rational expression is equal to 1 is if the numerator is equal to the denominator. Subtracting x from both sides and adding 3 to both sides, we will see that x is equal to 8. Since 8 is greater than 3 halves, we can conclude that the solution to this equation is x is equal to 8. And we are done.